So I am Dr. Janet Six, Senior Product Manager here at Tom Sawyer Software. And today we're going to be talking about how to visualize and analyze dynamic graphs over time. And this includes analyzing the past and doing a post-event analysis, also planning for the future by using simulations to understand different results with what-if analysis. We also talk about the ability to spot emerging trends as well. So how are we going to do that? Well, first, we're going to talk about what is dynamic graph data. What are the characteristics of the data being dynamic? Also, what are the implications of dynamic change for visualization and analysis? Then we're going to talk about visualizing the changes with timelines and animation. And then we'll discuss how to visualize the changes with a static visualization. And then we're going to talk about applications of this type of visualization and analysis to apply post-situation event analysis, simulate future scenarios with what-if analysis, and discovering and communicating trends. And then we'll answer questions that you may have. So first of all, what is dynamic graph data? So we might have the addition of nodes or edges, or the removal of nodes and edges. But also it can include more than the adding or removal of some nodes and edges, but actually the adding or removal of entire subgraphs. You also may have a graph that keeps the same topology, meaning the same nodes and edges, but you update the attributes within those elements. So you can update specific descriptive attributes or the timing of when those elements were updated. So what are the implications of these changes? Well, you may have a new graph topology because you have new nodes or edges or subgraphs, or you may have data updates which need to be highlighted and trends to discover. And so for overall, this means that we have new insights which we need to discover and communicate to stakeholders and decision makers. So let's take an example here of a graph that's changing over time. So we have here at the top the social network for a crime network and investigation. And down here, we have what's called the timeline view, where we can see how the relationships in the social network here in this crime ring are evolving. So let's take a look. So we're going to play an animation, and you can see here along the bottom where the blue bar is moving, showing us how far we're moving through time. And at the top here in the drawing view, you're going to see how the social network is growing and changing over time, and how the smaller subparts of the crime network are growing. And then we see those smaller groups connect together into this larger group. So now here at the end of our animation, we can see that there's many tight clusters or subgroups within our larger crime network. And then we can see how are those smaller groups connected for the whole. So the small groups and the large groups, we're able to see those in our visualization. Now, we were just looking at the topology or the who's connected to each other, or who are doing crimes together. But let's say we want to know, well, where are those crimes happening? And so we can do that. And actually, this will be a view of the same data, but we're looking to see where are these crimes happening. So again, we're going to have this blue bar moving across the bottom of the screen where we can see how much activity is happening. And in the map view at the top of the screen, we're going to see where we're having more crimes occur. And so this gives us a zoomed out view at a high level geospatially where are we seeing these criminal activities. But we also can zoom in to see details. Exactly where are these happening? So again, same data, but a different viewpoint. And so now we can see the actual location and specific details about which type of crimes. So we have some assaults, car thefts, and burglaries. And then we can see where there's greater activity, we start to see a number, meaning that there's multiple crimes happening there in that area. So we see some growing hotspots here. Very good. So having the different perspectives, the different views into the same data can help us create that larger picture and to discover more trends of what's happening. Now, here in these last few slides, we were looking at a crime network. And so the approaches that we talk about today, yes, those are useful for investigation and criminal network or looking for financial fraud. But these techniques and approaches can be used other places as well. They can be used in support for logistics planning. They can be used to study systems engineering and the building of complex products such as airplanes or automobiles. You might want to study supply chains and understand the where and the when and the what is happening. So these type of techniques can be used across many industries. Okay, so we had used these animations, these timeline views to show us the graph changing over time. But there's several different ways of doing that. The graph is changing over time, but how exactly do you want to see that? So here we're looking at where we're adding to the graph over time. So the graph is changing in front of our eyes, and as we have new data come into our system, we're going to update the visualization and add things, as you can see here. So here we're looking at another social network. We see it filling in over time. And sometimes it's what we want to see. We want to see what's new, what's been added. But sometimes we have data that ages out old data. So we can do that here as well. So that previous animation, we call that play left. Now we're going to look at play right. We want to remove the old data and take it out of the visualization. So let's see how that looks. So here we're going to start our timeline view animation. And as data ages out, we take it out of our visualization. And so another way to look at this same data, by the way, this is the same data as before, we're just having different views into it. The next thing we're going to look at, we call play both, meaning that we're going to look at a snapshot of a particular time period. We want to know what happened on a particular day, particular week, particular hour, whatever unit of time is appropriate for your use case. So let's take a look and see how we can use these timeline views to see a snapshot. So we have the different activities that are happening on different days and just those. And so what you see here with perspectives is that we defined a timeline view, and here at the bottom of the screen, we have where you can see when the activities happen. And you get to decide, do you want to add things over time? Do you want to remove things over time? Or do you want to see a snapshot? That's something that the end user gets to decide when they're running the application, what type of information they want to see. And then this timeline view is synchronized with our drawing view. So we can see what's happening in the timeline view at the bottom and the related data here in the drawing view at the top because the views are synchronized in perspectives. Right. So we just looked at several different ways to look at dynamic data where the visualization is changing in front of our eyes. And That's appropriate for some use cases. And other use cases, they want to have a concept of time, but they don't want to have the changing graph. They don't want to see things moving over time. And so they need a static visualization. And so that's what we're going to look at here. So again, we have events and we're having them happen over a period of time. But this visualization is going to still show us when these things happen. So let's take a closer look. So here on the left side of the visualization, we have these blue nodes, which represent our actors. These actors cause certain events that are shown here in yellow. And so we have an edge between a blue node and a yellow node if this actor caused this event. And then we have other events which occur in response to previous events. So we can see here, for example, that this event caused this event. So the edges are showing us the actors that are involved, and then also the flow of which events were causing following events. And then you'll notice that we have the nodes organized into columns. And that is showing us the days on which these events happened. So we're getting that concept of time in the static visualization. So as we continue on for about a week, we're going to see, well, there's some more blue nodes here. So that means more actors have come into the system and they're adding to the events and responding to the events that have occurred previously. So you can get that concept of time either with the visualization changing or with a static visualization that shows you by organizing things into columns as we do here, what happened when. We also can use swim lanes for something similar, again here with a static visualization. So we're looking again at some events that have occurred and also some characteristics. So we can see here in the columns the time. So in this case, we're looking at particular hours within a single day. And then we have events which occur, and we can divide those events into the rows. So we see we have first type of event up here, second type of event down here, and then we have the edges that are showing that flow or that dependency that happened between the events. And then down here in our last row, we show characteristics of those particular events. And then we can see an edge that connects an event with a particular attribute type. So two-dimensional swim lanes can also be used to show us a static visualization of dynamic data. Now, here is another way to look at dynamically changing data, and that is to visualize just a piece of a larger structure. So here we're doing some fraud analysis, and we are looking at a set of suspicious transactions that have occurred with some credit card accounts. So we see here that we have several financial transactions, and we see here the node label is showing us the size of those transactions, and we are able to connect those with an edge to the originating IP address. So all 5 of these transactions came from the same IP address, and what's especially important about that is that they have all occurred within 1 minute. So we have a substantial amount of financial transaction coming from one place very quickly. So this is indicative that it is suspicious and we need to study further because maybe there is a bot at this particular IP address and it is potentially making these fraudulent transactions. So we should look further. And so while we're investigating these, we need to know more information. Well, which were the accounts that were associated with that particular transaction and which merchants were involved? And so we can interactively investigate and continue to load neighbors and find out, are there other suspicious transactions that are happening from this potential IP address or these merchants or these accounts? But to narrow it down and show particular analytics results. So in this case, we're looking to see, do we have a pattern where we have many transactions that have occurred within 1 minute that all add up to a certain amount from a single address? And so we're able to do that here by focusing in on that part of the structure. And we're using the attributes based on those elements to show all of these transactions happen very quickly. So we can use these different techniques to apply analysis after the fact, post-situation analysis. What's happened? And so here we're going to take a look at a system, which we have here on the left side. So this is our original data of our system. So these might be components of things that you need to come together to create, for example, a certain product, or maybe they're products you need to bring together to manage some shipping in your logistics. Or it could be a set of processes or people working together to accomplish a certain task. Could represent many different things. Okay, but we need to narrow down to what is the most important information that we need to know. So we can apply a series of analyses to find out what's the most important. So you can see here the difference from the left side to the right side is that now we have color coding. And so the color coding is going to show us a ranking of the most important elements in this system. We have the green ones turn out to be the most important here at the top. And over here on the right side, we can see those elements with that same coloring showing us importance. Okay, so now what can we do with that? We want to get to the most important part of our system. So we do a second analysis with root cause. And we're able to focus in and narrow down the most important part of that structure, which we have here. And then we take that same structure and we do a different layout. So this is the same graph here with symmetric layout, and then over here with hierarchical layout using our orthogonal edge routing. And as an investigator, we want to look more. We want to understand about the important paths between elements in this core part of the system. And so we can select a couple of nodes. So I'll select this one at the top and this one at the bottom. And I'll say, show me all of the critical path between these two elements in the system. And you can see that those have been highlighted in red. So we used the analysis to narrow down to the most important part of the graph. And then we wanted to see with another analysis, where are our critical paths in the system? So here we're looking at a snapshot of the system. What we also can do, we can apply this type of analysis to several different points in time or to several different parts of the system and looking for overlaps and looking for trends in where the critical part of our system is. Okay, so we use the visualizations and the analysis to get us down to the information that is most relevant. And we show here with these red edges and these nodes of different color. Right. We also can use dynamic graph visualization and analysis to simulate future scenarios. So here we're going to look at a supply chain. So we see here on the left side in our tree view that we have different products that we are managing the supply chains for. And then over here on the right side, we're going to see the elements that come together to create components, which go together to create other components, and then over here to the final product. And then down here, we have some tables with some information about the particular elements and also their location and their status as well. So we're going to show what happens dynamically when you have a problem in your supply chain. So we're going to look at an example where one of the elements becomes unavailable. And we want to know where's the problem in the supply chain and where are the problems going to happen downflow of that. And then also we'll take a look geospatially, where is the problem? All right, so let's take a look. Okay, so we select an element and we're going to update that that element has become unavailable. Let's back that up for a second. So down here we have in our inspector view the details for a particular element. And so let's say there's a fire at the factory which makes this plastic element. So we update the production value to 0. So now I did that here automatically through the interface, but if you need to do that programmatically, you can do that as well. So now you notice that, and I'm going to just back this up just a little bit more. So here is our original visualization. And watch again, as I update the production value to 0, look how the visualization will automatically update and show we have a problem in red. So I update the value, I don't change anything in the drawing, Perspective will do that automatically. So update to 0, and then you see how things turn red. So we have that automatic show of the problem. Now we're going to focus in to just the problem area. So we just see that part of the graph. And then we're going to go to a related view, which is showing us where is this problem happening geospatially. So in the related view, so you can see that the same element was highlighted in our supply chain view. Now the same element is highlighted in our location interaction view, which is showing us the name of the factory where that element was made. And then we can also see the geospatial location, the country where this is located. So now here we're doing this type of visualization where we're using these nested drawings to show us which factory and which country or which region is this problem. If you wanted to show things with a map view, you could do that here as well. Okay, so now let's keep looking. So now before we had zoomed out and or we had zoomed in and we had wanted to see the problem with that particular chain. Now we're going to go the other direction. We're going to zoom out, which is what we've just done here. So you'll see where all of the problems are in all of the chains across our organization at the same time. So you can use this type of approach to do a post analysis, or you can simulate several future scenarios. So like, for example, if you're a supply chain manager and you want to look and see, well, you know, what is our maximum output, or what is our least amount of time we need to produce a certain number of products. And so you can run several of these different scenarios through this an application like this to see, you know, how do we, where's the result where we have the maximum output and the least number of problems, or the most that we can do in a certain amount of time, whatever it is appropriate for that particular use case. So another way that you can simulate future scenarios is to look at tasks and their dependencies, and also to understand their durations. So I'm going to bring over here from my other screen. All right. I have this application running live. So we see here on the left side, we have a set of tasks. We can show them by category. We can show certain people which are working on tasks. We can see who is assigned to a particular task. We can see a summary of how far are they through their task, what's complete, what's their estimate of what they need, how much time they need to complete their other tasks, and so on. And here on the right side, we have several drawing views. I'll come back to those in more detail here shortly. Down here, we have our inspector view, so we can see details, in this case, for a particular task. And then down here, so you notice like when I highlighted a node, how it changes what we see in the tree view, the inspector view, and the table view, because all of our views are synchronized. And then we can see the people and how much availability they have to help create and complete these tasks. Okay, so now let's go into some more detail here about what's going on here in the drawing view. And actually, we have 3 different drawing views. All right, and again, working with this same original data. So first, we want to just see, well, which tasks um, are related to other tasks, or which tasks are dependent and must be done before a following task is done. And then we have another drawing view that's going to show us, well, how long are these tasks expected to take? And so if it's a bigger task, then of course we have a bigger node. And then we also look at the tasks remaining. So we don't want to look at the whole system. We just want to know, where are we? What do we need to do to get this project done? So depending on which part of the project management you're doing, you need to see a different view. Okay, so now let's take a look at here into the task duration. So, again, the nodes are related to, how long are things expected to take? And of course, as we all know, as you're working on larger projects and tasks, you can update the need for the duration, because sometimes, you're going to need more time than you need, or maybe you're able to finish something more quickly than expected. And so we can um, update our estimates. So I highlighted this task here for implement feature number 2, and we see the details down here in the lower left corner. So our original estimate was 6 days. And it turns out that now, with more information, we think that we can get it done in 4. So let me update our estimate here. So I updated the estimate, and then you can see how the node changed automatically. So let's do that here with another one. So here's another task for documentation. It was originally estimated that we would need 5 days for it. Let's go ahead and update the estimate, because with the new information we have, it's not going to take as long as we thought. So it's only going to take 3 days. So I'm updating here in the attribute right here in the data, here in the inspector. And by the way, so if you're making changes to your data and you need to write that back or commit that back to your original data source, you can do that with many different data source types. So we support that as well with perspectives. Okay, so I'm going to update the estimate of time down here. And when I hit the enter button, watch and see how this node is going to change right in front of your eyes. And then we can see how that duration shrinks. So you can run several different scenarios through your system to understand more about, like in this case, how long are things going to take? And also, you can look for areas where you can parallelize effort. So we were just talking about project tasks and getting things done, but imagine if we were instead visualizing the machines in a factory. And we're looking at the machines which are responsible to build certain components and then to end at their final product over here. Now, what you can see with this visualization is that we have an opportunity to parallelize efforts. So if we were able to either use our factory differently or to add some more machinery, we could actually do these tasks and these tasks in parallel, which means that we would be able to create more products in less amount of time. So the visualization not only helps us understand the system by modeling it, it also helps us to see where we can optimize the system. So we also can use these different types of approaches and these different types of visualization to discover trends. And so we're looking here at a business process. And you can see here in green the tasks which are done. And then over here, we can see a process and then a sub-process within that, and then a sub-process within that. And we can see what is currently in process here in the yellow. So this is our current task. And again, we've gone several levels down, sub-process within a sub-process. So we can see here when we're studying the instances of business processes, for example, where are we getting stuck? So maybe we have a problem with our process, or maybe we have somebody who's overtasked and we need to add more people to get certain tasks done so that we can get past sticking points more quickly. Another thing that we can do is to compare versions to look for trends. So here we're looking at two versions of the same business process. And we can see here where things have been added. For example, here, the green, so this is a new element. The yellow indicates there's been a change to that task. And then we can see here from an earlier version of the same process, we have an element that's red, it's been removed, no longer there. So we can study the trends by comparing graphs. Now, the general problem of comparing two graphs and saying, are these the same? Or there's been changes, that is generally considered unsolvable. But when you have a specific use case, like for example, here with the business process, we know something about the graph, which allows us to benefit by seeing where are there changes. So again, general problem, it's not solvable, but when you carefully apply graphs, then you can solve some of those problems. In this case, we can show where the processes have changed. All right. Now, you also can discover trends by running analytics on several different scenarios. So, for example, some different what-if scenarios. So, we are looking at a system here, and we've run an analysis looking for vulnerabilities. And you'll see how some of these nodes have become red, which means if we remove those red elements, our system becomes disconnected. So if this is a communications network and we're looking to see where are our weak points in our communication network, we know that if we remove these red nodes, we're going to start to see parts of our system that can't communicate with each other. So this can tell us where we need to maybe add another element, another backup element, or we need to have more communication links. So you can update the system and then apply that analysis again. Where are our vulnerability points now? And so you can combine this with other types of analysis to understand which parts of the system need to be most fault tolerant. And then you make sure that that part of the system doesn't have any red nodes so that you have a more robust and reliable system. And another thing that you can do is looking for natural clusters in your system. There's natural groupings in the topology, and what do those tell us? So here we're looking at a pretty large graph, and we need to understand, well, what's happening here? What are the most important parts that I need to know? So we can apply a clustering technique, and we can categorize the elements as we've done here, and then zoomed in or filtered down to just show us the most important elements or clusters within our group, within our structure. So again, we can update our graph, and then we can study what is different and how is that important to our system. And so once we have these different types of visualizations, then we can bring that all together and communicate that to our stakeholders. Thank you for joining us. In today's webinar, we discussed the importance of visualizing how data changes over time, several methods to visualize dynamically changing data, how to use these types of visualizations and analyses for event analysis, simulations, and what-if analysis, and also for trend detection and communication of these key findings to stakeholders and decision makers. Contact us today at tomsawyer.com to find out more about Tom Sawyer Perspectives or to start your free trial. Also, please reach out to schedule a call with one of our graph and data visualization experts. We can help guide you to the best solution.